so what we got? So here we go. So William, you can see there's a strongly disagree on the left and strongly agree on the right. So this is what you've got to work with, Chris. How does that look? Is that what you're expecting?
I think that is what I was expecting. Yeah, I think my nightmare scenario is always I do a talk and I try and make sure it's accessible for everyone, and there's loads of people just bored, thinking, "Oh my gosh, I know all this. Shut up." But I don't think that's going to happen today. So that's
no, it definitely won't happen today. So, do you feel poised and well informed to proceed with the rest? Okay,
fully
great.
poised.
I will move on to the next slide, which is simply if people have any comments for you, then they can put them on this slide. But we can talk later. Marvelous. I will. Have I stopped sharing already?
Yes.
Yes, I have. Over to you, Chris. Go for it.
Cool. Thank you very much. Right. Let me just get my slides, which are here. Yeah. So I think I presented at a Huddle ages ago, I think, but I'm new in post at the strategy unit. I'm in the data science, we have a new team in the strategy and the data science team. So if anyone's interested in me or anyone else in the data science team coming to a Huddle and talking about anything else, I just talked about RAP because it's all we talk about these days. But there's lots of things we talk about, so I'm very happy to hear suggestions. And also, if you think this talk is really boring and terrible, I'm also really happy to hear that as well, because I always like feedback. Okay, so today is all about RAP. I'm glad I asked that question at the beginning, because as I say, I never quite know who's going to come. So it sounds like people are in a position where they don't know a huge amount about RAP. In fact, there are probably one or two people in the audience who are thinking, I don't know what RAP is, so I'm going to come on to that very soon. Right, so what is RAP? So RAP, reproducible analytical pipelines, it's a concept that has come from central government. I can't remember when they started using it, but before we did, and they're quite a bit ahead of us. So we take lots of inspiration from our friends over in the civil service on this issue. And basically, I'm going to talk in more detail about kind of what a reproducible analytical pipeline looks like and what it's all about. But the very brief explanation would be it's a process in which analytical tasks are done using code. So they're not done using kind of points and clicks with mice, but they're done with code. And the object of the game is to minimize the amount of manual undocumented steps and to have a clear, properly documented process. So the idea is that you have written down the whole analytical process in code, but also you write stuff around the code that explains how it works and where the data comes from and all this kind of thing. And the idea is that it results in a process which is kind of quite transparent, easy to understand, and will reliably give the same result from the same data set. So this is a sort of concept that's reproducible science is very big. And our friends over in the world of science, they're very interested in making sure that they get the same result from the same data. And there's loads of famous examples where this has not happened. Loads of horrible errors in science where people have made a mistake and the analysis is completely wrong. And obviously that's a very serious issue. Using code isn't a way of eliminating those mistakes, but it is a way of mitigating them. And I'll be talking throughout about some of the ways in which you can use code to make your analysis easy to understand, more accurate, and more reproducible. So that's what RAP is. So RAP, to my great delight, was mentioned in the Goldacre Review, which was published, when was it? Last year, because I remember I was reading it in the hospital. And it says in the Goldacre Review, it's the core working practice that must be supported by all platforms and teams. Make this a core focus of NHS analyst training. Of course, this is the thing I was saying about how I talk about the NHS all the time because I don't do anything else. The Goldacre Review was about the NHS, but I think that, lots of people across all the public sector and certainly the civil service are interested in this. And is it a core working practice that is supported by all platform teams at the moment? No, it isn't. So I'm trying to work, if people will want me to and will allow me to make a world where it is the core working practice that's supported by all platforms and teams. So let me tell you about it. So I'm going to talk today about kind of, if you're interested in this methodology, kind of how you start. I think something that I've noticed going around talking to all sorts of people, really, managers and analysts and whoever, is I think sometimes RAP can seem very kind of arcane and complex and weird and scary. And I think the reason for that is because people kind of look at the final result. So it's kind of the equivalent of kind of, I don't know, you go to like a woodworking course or something, and someone shows you this incredibly amazing cabinet with, and you look at it and you think, wow, like I can't do that. And that's not very helpful. There are, the whole methodology around this has got loads and loads and loads of things in it, and some of them are very easy. I mean, some of them are extremely easy. You just have to know about them. And as I'll be saying throughout this talk, if you make incremental steps along that journey, you will find that you are getting better all the time. It's not something where you have to be perfect from day one, and it's not something where you even have to do all of it. And in fact, I'll say later on, actually, there's bits on some of the guidelines that you really just don't need to know ever if you don't want to. So I'm just going to promote the idea that you just have a go, and there are lots of ways of being helped as well, which I'm also going to talk about, and see where you end up. Right. So why are we doing all this? So one of the reasons why we write code in the way that we do is to make it kind of predictable and reduce the mental load. So the example I would give, you get these sort of tech billionaires, and I think it's in the film The Fly as well, I think the 1980s version. They have the same outfit every day. So it's one, they say, oh, it's one less decision. They get up at like 4 o'clock in the morning, these people, and then they go and run their billion-dollar companies all day. And it's one less decision. And I think some of the practices we have in reproducible analytical pipelines are like that as well. We do things a certain way because we just do them that way. It's something else that you don't have to think about. You don't think, where do I put my code? Where do I put my file? Where do I, it's all done in a set way. And the other reason why that's really good, and something that's really important about reproducible analytical pipelines and this whole way of working, is it needs to be legible. It needs to be legible to you, and it needs to be legible to other people. So we have this thing called the truck factor, which I think is probably a bit of an Americanism. I wonder whether I think we sometimes call it the bus factor if we want to be a bit more British. And what the truck factor or the bus factor is, basically, it's the number of people who need to be hit by a bus to stop your analytical task from working properly. And there are lots of analytical tasks. I've certainly been involved in loads myself, where the bus factor is 1. I've been a bus factor of 1 in many of my projects. I think, quite honestly, probably for the last 5 years in all of my projects. And there are lots of reasons for that. But one of them is because things are done in an idiomatic way. They're not done in a set way, and they're not documented properly. So that's one of the things that we're trying to do. We're trying to just write stuff down, do things in a consistent way, so it makes sense to our teammates. But also, it must be said, to ourselves. So I wrote some code a little while ago, and I shared it with a member on my team, and I said, oh, well, here it is. This is the code that does the thing you're asking about. And I looked at it and I said, to be quite honest with you, I have absolutely no idea how this code works. I haven't got a clue. And I'd written it, I think, certainly less than 12 months ago. And that was, to be honest, that was quite frightening, because I did that quite recently. I think of myself as being reasonably good at this reproducibility lark these days. And I was quite shocked to find that I'd written some code and I was now sharing it with someone and I had no idea how it worked. So clearly I've made a mistake there. So it's just worth remembering that when you're writing all this stuff down, you're not necessarily writing it down for some person in the future after you get hit by a bus. You're writing it down for yourself in 6 months' time because you're an imperfect human just like me, and you're going to forget. So that's the first thing. The other thing that's really useful about some of these ways of working is it allows you to kind of move around more easily. So when these things are done properly, we find that we can kind of reproduce the software environment very effectively. So some of the examples of failures in science that I've mentioned, some of the problems have been that they've done it with slightly different tools, slightly different versions of software, slightly different versions of packages. There have been little tiny differences in the environment that they've been in, and that's made all the difference. And it's changed a kind of key result, and that's caused it to fail. The other kind of failure is the better one. So sometimes your environment will change for some reason, and the whole code will just not run. And that's very annoying because someone says, oh, I need this result, and you rerun the code and it doesn't work, and that's very annoying. But at least you know that it doesn't work. The worst kind of failure is the one that they've had in reproducible science, where you don't know that it's changed, and then all your answers are wrong and you don't realize. So it allows you to reproduce what you're doing, and that's just useful in general all the time. So it means you can use a different computer, you can use a computer on a server in the cloud, you can use it on a computer because you get a new laptop in 6 months, whatever it might be. You can use it on your friend's computer, whatever it might be. So these practices that I'm going to talk to you about also make it really, I think one of the key things is it's almost like reducing the kind of the stress. I think as I've learned more and more, I used to constantly worry all the time that I was making mistakes because there were so many things that can go wrong. And I think these are kind of, it's a bit like a checklist. They have them in kind of surgery and like when they're flying airplanes. So they have these like, have we checked all these 5 or 6 things? And that's what some of these principles are all about, is making sure that we're remembering to check everything and do everything right the same way every time. So that's really important. And another principle that we're going to use quite a lot in this world is the principle called DRY, don't repeat yourself. And what that means basically is that sometimes when people do start using code, they will write the same code over and over and over again, but they'll kind of change it slightly. So they'll write a piece of code that calculates the average age for someone or other, or whatever it might be, and then they write another very similar piece of code halfway down the page that does something almost the same but a bit different, and they change it. And this there's 2 reasons why you don't want to do this. The first one is because you don't want to make mistakes. So quite often when people are constantly retyping and typing code, they make mistakes. They don't change something that should be changed, or they do change something that shouldn't be changed. Something changes and they don't notice because it's just loads of kind of garbled symbols on the screen. It's not that obvious that it's wrong. And it's got a mistake in it. So that's the first reason why we don't want to repeat ourselves, because when we repeat ourselves, we often make mistakes. But the second reason that we don't want to repeat ourselves, and this is something else I'm going to be coming back to, is just because we're lazy. That's why. So, I think when you get one of the really kind of things that will motivate you into work in this way is just because you can't be bothered not to work in this way. And so constantly writing and rewriting and rewriting and rewriting lots of code is boring, or for that matter, even if it's not code, even if it's like Excel or SPSS or whatever your poison is, doing the same thing over and over and over again is really boring. So it's boring and it's a waste of time. So it's nice to streamline. Don't repeat yourself. Do it once. Do it really well, really accurately, and then just leverage that work to do it over and over and over again. Right. So those are some of the fundamental principles of why we're doing what we're doing. And I'm describing basically a process that we're going through in the strategy unit. And I forgot to say at the top of this, actually. So if you're in the NHS development program in the strategy unit, you will already have realized that this is almost exactly what I said to you the other day. So apologies for that. But I liked it, so I thought I'd say it again, basically. So I won't be offended if you sneak out at this point. So this is what we're doing in the strategy unit. We're looking at NHS Digital have got a community of practice around RAP, and they've published some stages, which we're going to look at in a minute: baseline, silver, and gold. And I'm roughly going to look, we're looking at kind of analyst development, and I'm roughly structuring what we're doing around the levels of the NHS Digital RAP stages. I have to say, and this isn't a criticism of the work that's gone into the stages, they don't perfectly meet my needs. I don't completely agree with all of them, but I guess that's just because people use RAP for different reasons. So I personally would very slightly reorder them or kind of change them slightly, but they're a reasonable framework, and it's something that you can point to. And certainly in your organizations, I think it's quite useful. Sometimes if you go to people and say, "Oh, I want to do this new thing that you've never heard of," they'll, that can be a difficult conversation to have. But saying, "I want to get our team through the NHS Digital's RAP stages," I think, it gives you a bit more backup that you actually are doing something that's kind of a good thing to do. So that's what we're doing. So as I mentioned at the beginning, there's a lot to learn. So this is what I want to. I don't want to put people off. You can almost drown in this stuff, really. But that's not a bad thing. That's a good thing, because it means there's lots to learn. It's really fun, and that's why I do the job that I do. But don't be put off by that. You don't have to kind of, you don't have to boil the ocean. Just do what you can. So let me just quickly whip through my slides, because I need to just tell you everything that I don't know, just to illustrate the point that it's not all essential. So these are the gold standards. So, I mean, I sort of know a bit about some of these, but certainly the CI/CD thing, I mean, I know what that is, but I've never done it. I think it's very clever and useful, and I think I could have done it in the past, but I haven't really bothered. I couldn't, I certainly couldn't do it without learning quite a bit. Event-based triggers also kind of maybe a bit with a lot of help, but it's not something I'm particularly good at. And the other two I'm not too bad on, actually. We will come back to these. Testing, again, is something that I think a lot of people would admit that they're not brilliant at testing. So I'm just saying, you can consider yourself to be someone who can use reproducible analytical pipelines, as I'll come back to, without kind of feeling like you've learned the whole kind of RAP dictionary. So don't worry about that. Just do what you can. Yeah, so you don't need to do it all at once. You don't need to do it at all ever. You can just learn half of it and then just go, you know what, that's fine for me for the rest of my life. I'm bored of this. I'm just going to learn something else now. Everything you learn will incrementally help you. It's not, as I mentioned at the beginning, it's not a package. You don't have to do absolutely every single thing perfectly. And that's why, so the people in my team and me, that's why we learn this stuff. We didn't learn this stuff so we could progress through the NHS Digital RAP stages, because there were no such thing as NHS Digital RAP stages when we learned this. We learned it because it helped us, and everything we learned helped us, and it helped us for two reasons. And this is why I mentioned the fundamental principles at the beginning. The two main ways that it helped us is, the first one that it helped us with is not making mistakes. So the usual route of learning stuff in life is you make a mistake and it's horrible and embarrassing and terrible, and you go through a lot of trauma about it, and then you resolve never to make that mistake again. And I, throughout my career, have made lots of horrible, terrible mistakes with analysis and felt very silly, and then gone away afterwards and thought, I'm never going to do that again. That was horrible. And that's very often led to me doing one of these things, whether it be documentation or testing or whatever it might be. So that's the first thing that is good. But the second reason why we've learned these things is because we're lazy and we get bored easily. I do get very bored very easily. Actually, my wife constantly takes me to task on this. I don't want to just sit and just crank stuff out. I get very bored very quickly. So learning this stuff, it makes you quicker, it makes you less bored, and it means you're having more fun. Or certainly, if you're me, it does. And I think certainly if you're a lot of people, it does. If you start learning this stuff and you're not having fun, I don't know, maybe it's not for you. I don't know. But that's a question for you. So that's why we learn this stuff, because it's helpful. Right. So having said all that, all my cats come to join us. Welcome, Pavlova. Let's pop you there. The baseline level. The baseline level, I have to say, is pretty low, actually, and I think that's really good. Well, I was surprised when I read this that it was so low, but I think that's really cool, because what they're saying is, the baseline, to get started, you don't have to do a huge amount. So I think that's really good. Having said all that, there are some surprising things in here. So let's just have a look through it. So the first thing you have to do to be baseline RAP is you have to write code in an open source language. So that obviously is, as long as you are writing code at all, that is pretty low. If you're not writing code, obviously that's not all that low. But clearly writing code is part of this. So that has to be on the baseline. So you have to write code of some description: Python, R, SQL, whatever it might be, Julia, if you want to be new and flashy. So that's simple enough. Right, version control. So I'm not going to have time to go into detail about all these concepts, but I just want to give you a flavor about what they're all about to kind of inspire you to learn more. So version control in code basically is all about checking and recording where it's changed. So again, this is all to do with reproducibility and accuracy and legibility. The idea is that when someone adds some new code or deletes code and changes it around or edits it or whatever, there's a record of that. That's what version control is all about, and that's very, very, very helpful for lots of reasons. But the main reason is because if something goes wrong, you know why. So if you work on some code and you're doing all this thing, and then all the numbers are horribly wrong, then you think, oh, what have I done? And you can step back. The first thing you can do is, of course, you can just roll back to a previous version. So you're about to go into a meeting, and I've done this many times. You're fiddling around with your code. You're about to go to a meeting and show the code. You break it completely and think, oh my gosh, roll it back, job done. But the other thing you can do when you're in a less high pressure thing is figure out what went wrong. And there's a wonderful thing in Git that I love the name of, because it just makes me laugh, called Git blame. And what Git blame means is it will tell you who wrote every single line of code. That's why it's called Git blame, because then when people make a mistake, you can blame them for it, but obviously in a nice way. And so it's really important when you're working in a team. So if you've got more than one person working on a code base, and something goes wrong, it's really helpful to know that whoever it was, Steve, changed line 17, because then you can go and ask him. You can go and say, what's up with this? And they'll say, why ever they changed it. That's version control. That's really important. Repository includes a README file. So basically that just says when you go to a GitHub repository with a load of code in it to run an analytical task, there's a little thing on there, little note that says how to run it. It doesn't have to be incredibly detailed and tell you how every single line of code works, but it must say, hello, this is the whatever analytical task. It uses this data, and I did it for this reason, and it produces this. And all that means basically, it's pretty much if you get hit by a bus and someone comes the next day and says, hey, have we got that analysis? Somebody can go on, read the README and go, oh, yes, here it is. This code does this with these inputs. Run it. Off you go. Done. So that's really, really important. Right, and then these last two I think are more hard, and I'm surprised they're in here, but they're both cool, so I'm not complaining, but they seem to be a bit more silver to me. So the first one is peer review. Getting your code reviewed is really, really, really important, and I recommend it all the time. I don't think anywhere near enough of it goes on, and I'm guilty of this myself. Having your code reviewed doesn't have to be reviewed by an amazing, expert. It just has to be reviewed by someone who can understand it. They just have to be somewhat at your level, basically. Because even if they're not giving loads of amazing advice and saying, oh, well, if you change this, it'll run 10 times faster. You're not really even looking for that because you don't necessarily want it to go 10 times faster. You just want to know that it's okay. Having someone to review your code will give you two benefits. Number one, they will tell you if it doesn't make any sense. They'll say, well, I don't really know what this code is even doing. Why the README is rubbish and I just don't really get it, because it's a fresh pair of eyes. It's way too easy to think your code's obvious when it's not. And the second reason, of course, is they'll spot mistakes. So they'll say, oh, actually, it turns out that if you do that, then it's wrong because of such and such a reason. So it doesn't have to be, and I think the word review, I try and downplay that actually when I talk about code review. It sounds very formal, like a performance review, like you go into a room with someone and they sit down and they explain to you why your code's terrible and why you won't be getting a pay rise this year. And it's not like that at all, or it shouldn't be anyway. It can be very friendly and fun. And in fact, loads of people in my team and in teams with my team have code reviews all the time, and they have a wonderful time, and they talk about lots of exciting things. And both the reviewer and the reviewee have a lot of fun. So I highly recommend that you find someone to review your code, and you can just do it. You can do it for each other, can't you? That's probably the best way. So that's that. And the last one is the code is published in the open. So people who have heard me rant about open source in the past will know that this is one of my favorite ones because I do very sort of passionate about this subject. Again, I think this is this doesn't feel very baseline to me. This feels more silver. But you should publish your code. It's government policy. I can do a separate talk about that sometime. So please do. And if you do, then you make sure you include a license. And I can do a separate talk about that too. Yes, go and read some of the civil service stuff. I should have put links in the slides, actually, shouldn't I? Anyway, if anyone's interested in open source and licensing and stuff, just drop me an email and I'll send you. There's loads. I've got loads of stuff, but I forgot to put it in the slides. Right, that's open source code. A bit of time, not too bad. Right, this is silver, so this is going up the ranks a little bit now. So now it says code is well documented. So now we're going from a world where you just write loads of weird code that nobody really understands, but there's a README that says, oh, press this button and do this, to code that's well documented. So the difference being basically that code that just has a README can be rerun, which is obviously really useful if you get hit by a bus. But code that's well documented can be changed. It can be understood and changed. And someone can say, in the often thing is people don't get hit by buses. I don't think I know anyone who's ever been hit by a bus, but people change jobs quite a lot. And yeah, so if you move to a different job, we want to be able to keep your code and change it, put new years in, add stuff, take stuff away, whatever. And if it's a confusing mess, we can't do that. So that's what well documenting your code is. It's writing stuff about the code that helps you to understand how it works and what it does. Code is well organized, following a standard directory format. There's loads of technical stuff I could say about that, but it's not terribly interesting. But it's clearly a good idea to do that, and it reduces mental load. Basically, that's one of the main reasons to do that. Is you're not constantly saying, "Do I call this folder the data folder, or do I call it like whatever it is?" You just do the same thing every time, so that helps you. But it also again helps if you leave. So if you leave and someone comes into what you've done, everything's just laid out clearly. They can see where everything is. So it's constantly thinking about legibility, basically. What does this look like to somebody that isn't me, or somebody that is me in 6 months when I've forgotten everything? Some of the rest of the stuff is a little bit more technical, so I'm not going to major on this. I think if the scores earlier had been a little bit higher, I maybe would have gone into this a bit more detail. But basically, what the rest of the points are more to do with writing code that is good in various ways that I'm not going to kind of go into too much. Reusable functions, basically, and classes that are a way that do not repeat yourself again. Really, it's about writing code that's kind of well organized and not repetitive, and it also is accurate, so it doesn't have lots of repetitive code typed in with mistakes in. A testing framework. Testing is really important. People don't do anywhere near enough of testing. In fact, someone was having a go at me about my lack of testing only the other day. So tests basically allow you, what you do is you can run your code and you tell your code, when you run this, the answer should be 17. If it's not 17, it's broken. And you write all the tests and you make sure, and the code will say, yes, no, it's all fine, it's still 17. But then if you change it and it says, oh, no, it's not, it's 34 now, you think, oh, dear, that's wrong, and then you go and change it. So that's really important. And I'm probably just going to miss out dependency information because that's a bit technical as well. Tidy data as well is something that particularly I think people from the R world might be familiar with, if you are familiar with the tidyverse way of doing things in R. Again, I could talk more about that. It's just a neat way of handling data. There is a link if you click on the tidy data in the slides, which I can circulate later. There is an explanation about what tidy data is, but it's widely regarded to be a kind of useful way of handling data because it kind of does things like reduce repetition and increase accuracy and that kind of thing. So that's Silver. So that's not too bad. As I say, that's, I think, achievable for most teams. Testing is maybe a little bit more towards the advanced level, and maybe the dependency information a little bit depending on what you're doing. But everything else is pretty much just what you should be doing. So I would certainly advise people to aspire to that level. That's what would be my advice. Not immediately, not straight away, but it's something that people can aim for. And then gold is slightly, well, I don't know, gold's a mixed bag really, so let's go through gold. So the first one is fully packaged. So again, that's slightly technical. I'm not going to go too much into detail about what that is, but just to kind of inspire you to get interested in the idea of packaging code. The idea of packaging code is, there's sort of two ways. If you've got a load of code that does something useful, let's say you write some code that does something useful, you can just send it all to somebody, go, right, there's this file, this file, this file, this file, this file, this file, and then they're going to find it hard to run it because you say, well, you need to run that one first, and it requires these packages, and then you have to do this, and you put your data here, and it's all just, and I've worked on projects that are like this, where you literally get these kind of 7 code files with all these weird instructions scattered all over them, and that's fine. That's baseline crap. But what code packaging does, basically, the non-technical explanation would be, it puts it in a neat little box. So it puts it in a little box, and you give that box to someone, and they don't need to know what's in the box. You give them the box, and they say, if you run this function, it will do that thing I told you about. And they don't need to worry about anything. They can just install the package and run it. So that's really useful. Packaging your code is really, 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 really super helpful. And if you've got common analytical tasks in your team, I would strongly recommend that it's a future that you work towards. Let's say there's no rush with any of this stuff, but it will definitely help you in the long run. It will help you, and it will help you help other people, which I think is probably even more important. CICD, as I say, I've never done that in my entire life. It's very clever and whizzy, and it will save you time, but I've never done it in my entire life, so I'm not going to tell it's super important. Event-based triggers can mean more or less depending on what the trigger is exactly, but it's just a way basically of knowing when some data has been refreshed and then fetching new data. So if you want some data set to be kind of continuously up to date for some reason, there are various, ranging from the extremely simple to the extremely complicated, various ways of doing that. And it kind of depends partly on how live you want the data to be. Often, in my experience, nightly is okay, and nightly refreshes tend to be reasonably simple depending on what they are. Sometimes you have something that's a bit more clever than that, and sometimes you have things that refresh at different times in a different order and whatever, and that could be hard to manage as well. But that's the basic idea. Basically, you want to give some sort of live data. And the last one again feels a bit silverish for me, but it's in gold. And that's just basically that you write the changes down. So there's someone in my team who's particularly hot on this, and I think that's really good. You always seem to have people who are hot on particular things. Everyone's got their drum they like to bang. And I think this is a really good drum to bang, because if you're using some code and then someone gives you a new version, but they don't tell you what's changed in it, that can be really unhelpful. So properly done reproducible analytical pipelines will be updated, they will change, but then you will have a list of changes, and then people can look and they go, oh, it doesn't do that thing anymore, or whatever it might be. It might be something really, really important. So as I say, that feels like quite, and it's not difficult. That's not a technical thing. It is literally just writing down what you did. There's no kind of like computer wizardry involved at all. I think writing down what you did is like that's just a rule for life, isn't it? And I think that's certainly true with reproducible analytical pipelines. What you did and why will really help people. Okay, so that's RAP, as I say. So I don't want you to be put off by how much of it there is, because, as I say, it will all help you. You can have as much or as little as you like. So this is my kind of rough, as I say, this is what we're doing internally. That's why I'm sharing it with you. This is roughly what we're doing kind of progressively, and it will take different people different lengths of time. Clearly, some people will be doing this for probably a year or more, and some people will just be like, bang, 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 no problem, depending on how often they're using it and who they are and what they know and whatever else. So the first one thing is just like tidying your code up. Legible code, I could do a beautiful talk on that, and in fact we are having a beautiful talk on that later today. So just writing code that you and others can understand and putting it in the right place, that's really, really important. Writing functions and iteration, that's don't repeat yourself, basically. That's writing kind of code that is easy to understand. I'm just trying to think, should I try and quickly sell functions here? No, well, I'm running out of time. Yes, it's about writing code basically that's easy to maintain and easy to read. It's easy to make sense of. That's how functions will help you, and it's free of mistakes as well. Git and GitHub, obviously are really important for version control. They're really important for sharing a code. I mean, I really love GitHub. There's loads of like project management, and there's loads and loads and loads of clever things that it does. I could do a very, very long talk about all the clever stuff that GitHub does. And again, GitHub, you don't have to be a master at it to benefit from it. You can just dip your toes in the water. And I've been dipping my toes in the water for a long time, and it can really, really help you. So I thoroughly recommend getting to grips with it. There's loads of good documentation as well. If you go to the GitHub site and go to the documentation, they've got loads of really, really, really excellent documentation. So have a look. Packaging your code, that's that thing I mentioned earlier, where you take a load of disparate code files and kind of shove them in a box, and then you can share them with people. That's really useful. I think I would argue every team needs at least one internal package, even if it's just to make all their graphs look the same. Even if it's something really simple, like, hey, wouldn't it be cool if all our graphs had a little thing at the top? That's the use for packaging. But you can do loads of clever things. You can have, like always that weird statistical thing that we all do, or all that weird database that we always spend their ages writing stupid code against. Let's just distill it down. So that's really helpful. Testing is really important. As I say, that's a way of making sure that you haven't broken stuff. That's the number one thing that you want when you're messing around with code, is you want to know that you've done a load of stuff and changed a load of things. It's properly version controlled. You know what you've done. You know who's done it, and you also know that it hasn't changed the results. And that's back to the reproducible science thing again. Is that when you have the same input, you want the same outputs. That's what testing is all about. As I say, we don't do nearly enough of it, particularly me, but it's a really valuable thing to do. And then the last thing we're going to look at is kind of package management and versioning, and that's just all about knowing which version of a thing that you're using. So that's just more about how all the different parts of the kind of computational environment that you've got all fit together. And that can be very complicated. There can be a lot of interlocking parts, and it can be often very difficult to identify which interlocking part might break all the other ones. So there's various things that you can do to make sure that you're basically running. It's basically about recreating the exact same environment wherever it is. There's loads and loads and loads of stuff on this, and you can do it to a very high degree of sophistication. But it basically boils down to, if I wrote some code on my machine and I give it to you, the code runs the same for you. So it's reproducibility again, but it's reproducibility across computers and across operating systems and cloud, whatever, wherever it is, it runs the same. Right. So how can you do that? I think the number one thing I would say is work as a team. This is very hard to do on your own. It's not impossible. Don't be put off. I came a little way on my own, but I've gone so much faster since I had a team. The team, I think, is the number one most valuable tool in all of this, well, in life, really. So yeah, work as a team, share, cooperate, hang out, code review, have fun, all that stuff.
Stop shutting that door.
Coffee and coding. We're running coffee and coding sessions in my team. There are coffee and coding sessions all over the place. I know the Cabinet Office have one because I cribbed some of the materials for my slides. There's loads in central government. They're all over the place. Set up your own. Just I don't have time to talk in detail about what coffee and coding is, but basically it's you go to a place and someone either says, hey, look at this cool thing that I made, or hey, look at this cool new technique that I learned, or it's basically about just sharing either things that work really well and are awesome, or things that are totally broken. So the other thing you can do in coffee and coding is you can bring something and say, I wrote all this code and it does not work at all, and I'm very frustrated. Please help me. So they're really fun. Ask for help. That seems like a very obvious point, but people often don't ask for help. So I run we run NHSR office hours, 1 hour every week. So there will be someone from the NHSR community sitting in a virtual room waiting to answer your questions every week. And there's obviously loads of other sources of help, not just NHSR. I'm going to talk about NHSR in a moment. So, ask your friends, ask your colleagues, ask people on Twitter, ask whoever. And you'll find, well, certainly if you ask me, as long as what you're asking me is less boring than what I'm doing currently, which it probably almost certainly will be, I will probably answer your question. Do pair coding. So pair coding, again, is really fun. It's basically 2 people writing code at the same time. There are lots of ways of doing that. Sometimes one person writes the code and one person supervises. Sometimes they chop and change. Sometimes they're almost both writing at the same time, kind of writing different bits. There are loads and loads and loads of ways of doing that. But again, it's 2 pairs of eyes, it's 2 brains, and it's learning. And they're bound to do something at some point. However brilliant or beginner you are, they will do something that you didn't know, and you'll be like, oh, I didn't know you could do that. And that will help you as well. So that's really useful. Get your code reviewed. I already talked about getting code reviewed. It's really, really important. As I say, you don't need to look for some amazing coding genius. That is not necessarily at all. Just somebody who's capable of reading the code is fine. In fact, even if they're a bit, not great at code, that is probably fine too, because then they'll ask lots of questions. So we say, well, what does this bit do? And you'll say, oh, and you'll tell them, and they go, oh, that's fine. And, I didn't know. So it's not necessarily about having this super expert. It's more just about getting someone to help you. And yes, I already briefly trailed NHSR. So we have the NHSR community, very helpful, brilliant group of people. We also have the NHS PyCom community. If you're more of a Python type person, again, also a very friendly, brilliant bunch of people. The NHSR community and the NHS PyCom communities are great friends, I should mention. We try and work together as much as we can because we're all on the same team, basically. So do all of those things and you will learn a lot, I'm sure. Right, that's me finished talking about RAP now. I'm just going to very briefly mention Hacker at the end. I could have just done this on my brain, but I knew if I didn't put it in the slides, I'd forget. So we have the first National Analytics Conference for Healthcare. Hacker, what does it stand for? Health and Care Analytics Conference. It's all about insight to action, basically decision making, strategic analysis, using data and analysis to improve decisions and what's going on, which is really awesome. It's July the 11th and 12th, University of Birmingham. We're accepting abstracts, so we've got posters, we've got short talks, we've got long talks. The abstract deadline is the 27th of March, and there is help available. So if you're not sure, and I must say I'm helping out with some of the abstracts. I don't know whose idea it was to offer help, but it was a really brilliant one because there were loads of people who've clearly they've done great work, but they're just not sure about the abstract, or they're a bit worried, or they've just never done it before. And they're emailing us and saying, oh, I'm not quite sure what to say, or I don't know what to tell you, I don't know what bit to sell, or whatever it might be. And we're offering help. So I'm really happy we did that. I think it's amazing. There's loads of people getting help. So please don't be put off. If you've got something to say, drop us a line and say, I would like a bit of help with this, and we'll be more than happy. We've got loads of brilliant experts, people who are much better at this stuff than me, helping out. And we can also help, not just with the abstract, we can help you with the poster, we can help you with prepare the presentation, we can help you know what to say, we can help you with all of that. So help is available, so please do come along. That's it.
Brilliant. Thank you very much, Chris. That was an excellent introduction to reproducible analytical pipelines for those people who wanted to learn a bit more about it. And I'm sure you've inspired people to want to learn more about it and to start to do it. There were a couple of questions put up, which I won't share my screen up because I think one or two of them you covered, because I think they were mentioned earlier on in your talk. So one of them was very much like what is the best place to start? And I think you covered some of that in one of your slides. But if somebody is starting from scratch, or they feel they're starting from scratch, how do you sort of get going on this?
Well, I'm going to answer the R version of that. So apologies
Yeah.
to all the people who are not Irish, but I definitely know the correct answer to this question. If you want to get started, here's what you do. The first thing is you join the NHSR community flag. The second thing you do is you sign up to an intro to R and R Studio session run by the NHSR community. The third thing you do is you join the NHSR community book group, which is a channel on Slack. And then you hang out in the NHSR community Slack and you do stuff and you work and you get questions and you ask questions and all that kind of thing. And if you do all of that, then I think you'll be well on your way.
Okay, that's excellent. Thank you very much. We also do that training via the MDSN route as well. So there's two routes to the intro to our studio and others as well.
That's a good point. Sorry, I forgot to say that. Yeah, of course, because I was thinking about NHSR. Yeah, to be honest, you probably get on quicker MDSN because NHSR is booked for months. So yeah, do that. Good point.
Yeah, absolutely. So we'll be just about to set up all those training sessions for the coming year. Another point was, is there, or are you planning to do any training on RAP itself? So you've talked about how to get started yourself, but are we planning, we've talked about how we might support people to on this journey. So, and have you got any sort of thoughts on that? Do we have any plans?
The short answer to that question is yes, we do. I've got all sorts of various weird and wonderful irons in the fire with all sorts of various wonderful people. I definitely want to offer RAP training to the MDSN. I'm not quite clear what the form of that is, but yes, we will definitely do that. In the meantime, whoever asks that question, just tell me what it is in particular you want to learn, and I can look at that whenever.
Okay. So somebody is saying, Chris, could you say something about the types of projects where RAP might be most helpful? Are you going to say all projects?
Well, I am, but I'm going to say it in a really long, boring way. Yes, no, I'm glad that you asked that question because I do often say that. There is a myth that I've heard. Well, I consider a myth that people can argue with as they like. The RAP is for very big, complicated things with lots of clever people working on them. I've heard that said lots of times. And I really don't agree with that. And that's because I've done loads and loads and loads and loads and loads of RAP stuff, and I'm really happy I did. And I've never done any big, complicated analysis like that in my life. My job's just not like that. I've done lots of little itty bits and pieces all over the place. And I always use all of these. Well, I don't always use all of them. It depends whether they're relevant. But I mean, I've always got them in my toolkit because they do all the stuff that I mentioned. They reduce your mistakes and they make your job more interesting and they help you and they do all this stuff. So I think there's a big mistake going on. It's not so much with analysts. I think it's with people who are instructing the analysts, waiting for this mythical thing to come over the hill, this so big and beautiful project that it needs all these amazing software engineering. Don't wait for that project. Just get stuck in, have a go, and you can come back in 6 months' time. You can come and tell me if you're wrong. If you like, you can say, "Well, I did all that stuff you said, Chris, on a normal project, and it was boring and it was a waste of time and it didn't work." I've never heard that. So yeah, please prove me wrong. But I think you will find that it's always you should always document your code. You should always version control.
Yeah.
There's never any reason not to.
And also, I suppose starting with smaller, less complicated projects is going to give you that sort of practice, isn't it, as well? So getting into the different sort of things that you need to be perfecting. Well, not necessarily perfecting, just rehearsing, so that when you come to those bigger projects, you're more sort of competent and comfortable with the approach. Got another question here. It says, this poor person is the only person in their team using R. That's not what they say, I'm paraphrasing. So how would they get their code reviewed and sense checked? What would they do?
That is a great question, and I have to say there are loads of people like that, and I'm very sorry about that. I'm trying to build a world where there isn't any lone R programmers, and that's an important source of truck factor as well. This is my message. If there are any like leaders and managers listening to this, you're building lots of truck factors into your teams by having these brilliant people using R with only one person. So that's not a good thing to do, but that's clearly not the fault of the person. I don't know. I mean, I've been asked this question before. I should have a better answer to it by now. You need to make a friend, basically. You need to find someone in the world who will review your code and you review their code. And I think the best place to do that is probably NHSR or NHS PyCom, depending on what your tool of choice is. Yeah, just ask around. I feel like there must be other people. Maybe there are 2 people on this call right now. Maybe 2 people are thinking, well, I'm looking for a friend, and they're instant friends. So as long as we've got an even number of people on this call who want that, job done. But yeah, ask around, find someone, and I think you'll find you've got a lifelong kind of code review friend.
Well, by chance, and I don't think it's the same person, but it could be, they've joined a new team. This is another question, another point, and they know our coding, but their current team uses Power BI. So what would your response to that be? Do you have a suggestion? So they're also, and that must be quite common. So and Power BI is a different thing. But if that is their main a team's main focus is to use Power BI, how does that fit in with the desire to learn RAP and apply RAP?
Well, yeah, we're getting into the meaty issues now, aren't we? 5 minutes before the end.
Yeah, why did I do that? I should have saved
that. No,
that
that's
for
fine.
later.
I'm sure people don't want to listen to me talk about it for 10 minutes anyway. It's a good question, isn't it? Yeah, I mean, Power BI is not RAP. It says in the Goldacre review that every platform and team should support RAP and should be the core focus. So, in my opinion, we need to start de-emphasizing some of these tools, and we need to start emphasizing RAP tools. But I would say that, wouldn't I? I think the way I would begin that, now is there's lots of clever analytical work that can only be done in R. So whatever you do with Power BI, I would have thought you would probably want to run stuff alongside it that's more statistical or more whatever it might be in that tool. And I would hope that over time, the R stuff, I mean, this is often what happens is you end up with analysis in R that's kind of better than the one that's being done with existing tools, and the R will kind of slowly kind of crowd out the other one. I mean, I think that's happened in general in the whole NHS is people are using these tools for their, and finding amazing things. And people are starting to ask, well, why are we still using all the other tools? Because they don't know all this amazing stuff. So that will be my hope. But as I say, that's a big question, isn't it, to do with, the demand side and all that kind of thing.
It is, and as you say, we've got a couple of minutes to go. So I'll try and draw it to a close. And I'm trying not to read the other questions, which I know you'll want to answer. So I'm going to share them with you later, Chris, if that's okay. And you've mentioned also, well, thanks very much for sharing everything you've shared so far. But you've mentioned a few things that I know people will want to know more about. GitHub, for example, is just an example. And you've mentioned other things that you said you could talk about. So, I mean, why did you do that? Because now you have to come back and you have to talk about these things because people will want to know about them. So I do hope that was okay.
I really want to live in a world where people ask me about data science all the time, and it's my job
Yeah.
to just tell them. I've been trying to build that world for a long time, and I'm getting there. So
well, you're
please
here.
do
No, you're
that.
here.
Yeah, exactly. Ask a lot of questions. That's why I got this job.
This is your stage.
Yeah.
I know we're going to be seeing a lot of you, which is great. Okay, there's a couple of questions about it's only being is it only don't answer them, these are rhetorical. Is it only effective if the data is robust? Obviously this is some of these are givens, and so on and so forth. Okay, but I will not allow you to answer that question, and I'm going to move on to the just last couple of minutes. I've just got a couple of things to share with folk. We've already mentioned the hacker, and we strongly urge people to submit abstracts. We strongly urge people to seek help if they've got an idea but they've never written an abstract before. They'd like a bit of support, some help and guidance, then they can contact Chris or me, and I'll put you on to Chris, so you may as well just contact Chris. And in the next couple of huddles, I'll just share my screen. We've got some excellent things coming up soon, so not the next one but soon we have a huddle entitled Weapons of Maths Destruction, and that's with someone called Hugh Day. I'm really looking forward to that. And yeah, so Chris, you're already coming back to tell us more about the new data science team that you are leading, and within that broad title you can talk about any one of those things that you've mentioned today, so that'd be great. And we've also got a session coming up on multi-criteria decision analysis. I think that's in a couple of huddles time. And I will just finish by saying it's at 12 o'clock. So the prospectus is being updated at the moment. So we do, as I mentioned before, most of the courses that we ran last year, we will be rerunning. And there are new ones as well, but we're just finding those dates now. So look at the prospectus, or actually look at the training and events webpage, and all of that will be updated on there very soon. It's 12 o'clock, guys, and you know what that means. It means I will see you in a couple of weeks. Thank you very much for coming. Enjoy the rest of your day. I'm going to go and play in the snow now, and I'll see you in a couple of weeks. So bye-bye.
Thanks, everyone.
Bye.